we're going to look at how you solve compound inequalities. So let's start with our learning target today. Our learning target is I can solve and graph compound inequalities. Before we can do that, though, we have to know what a compound inequality is. So what are compound inequalities? They are two inequalities that are joined together by either an and or an or. So they're going to look slightly different. So when we're doing these, what we want to remember is that an or is considered a union. It could be one or the other. We're putting them together. So ors are unions. On the other hand, an and is an intersection. It has to be both. We need this and that for us to go on a trip, whatever it is. So this is called an intersection. So they're going to look slightly different, and we're going to solve them kind of different, but pretty much the same way. We're going to end up solving two inequalities kind of at the same time. So let's start with our or one. So the or ones are nice because you're going to see the word or right in the problem. See, it's right here, or. So we're just going to solve each inequality separately and then write our answers together. So I'm just going to go ahead and draw this line down here between them and solve them. So I'm solving 7x minus 5 is greater than or equal to 65. So let me start with that one. So I'm going to add 5 to both sides. So I get 7x is greater than or equal to 70. Divide by 7. So we get x is greater than or equal to 10. Or, and then let's see what happens when we solve the other one. Our other one, we're going to subtract 2 from both sides. So we're going to have negative 3x is greater than or equal to negative 6. Now all our rules of solving inequalities hold. So in this case, we're dividing by a negative, so we're going to have to flip the inequality symbol. So our answer is going to be x is greater than or equal to 10, or x is less than or equal to 2. So on our graph, what we're going to see is two separate areas. So the first one is x is greater than or equal to 10. So I'm going to put a closed dot at 10, and I'm going to shade towards the greater than to the right. And the other part of the inequality is x is less than or equal to 2. So I'm going to have a closed dot again, and I'm going to shade to the left. So or graphs are always separated. One thing I want to point out is they don't have to have the same dot. One could be open, one could be closed. It just depends on the problem. Okay, so let's do an and one. Now there's two ways to see and ones. It might be written like an or, and instead of an or, you would have an and written in there. But a lot of times they're just shoved together. And what we're going to do is we're going to solve the middle part, because what we're going to see is the graph, both parts have to be true, so your shaded area is going to be trapped in between two endpoints, just like this equation is trapped in between two inequalities. So you solve it from the center. So you just focus on the 7x plus 6. So I'm going to subtract 6 to get the x by itself. But remember, we're solving two equations at the same time, so I have to solve both endpoints too. So I'll get negative 56 is less than 7x, which is less than negative 14. Now, to get x by itself now, I have to divide by 7. So I have to divide both endpoints by 7 as well. So I get negative 8 is less than x, which is less than negative 2. So you can see my x is trapped in between those two endpoints. So we're going to see that on the graph as well. So I'm going to go ahead and graph my endpoints. So I'm going to have an open circle at negative 8, open circle at negative 2, and I'm going to shade everything in between. And that's what the graph's going to look like. Okay, let's look at 3 practice problems. The first one is an OR, so I'm going to solve each of them separately. So I'm going to first solve the 7 minus 4x is greater than 47. So I'm going to subtract 7. Get negative 4x is greater than 40. Divide by negative 4. I get x, and again I'm going to flip the inequality, is less than negative 10. So I can go ahead and graph that. So I have a 0, an open circle at negative 10, and I'm going less than. Okay, and then I'm going to solve the other one, which is 5x minus 1 is greater than negative 26. So I'm going to add 1. So I have 5x is greater than negative 25. Divide by 5. And my answer is going to be x is greater than negative 5. So I'm going to go ahead and graph that. So I put an open circle at negative 5, and I'm going to the right. So you see there's 2 separate sections of the graph. Okay, next one is an and I know that because my x is trapped in the center. So let me go ahead and work from the center. I'm going to start by subtracting 1 from the center and from both ends. So I get negative 48 is less than negative 8x, which is greater than or equal to negative 63. Now I'm going to divide the center and both ends by negative 8. Now I'm dividing by a negative, so I have to flip both inequality symbols. And while the other end, whoops, I forgot to do the addition there, I'm sorry. That should be a 4. So that'll be 8. So my x is trapped in between 6 and 8. So that's the only part I'm going to graph. And then finally, this is the other way you see an and sometimes, and you can leave them separated like this. So we're going to solve each one separately, but the graph will look like our second example. So I'm going to add 1. So I get 5x is greater than negative 25. Divide by 5. I get x is greater than negative 5. And let me solve the other piece. I get 7x. I get 7x is less than or equal to 14. So I get an and 7 is less than or equal to 2. Whoops, I'm sorry, that should be an x, not a 7. So I'm going to have an open circle at negative 5, a closed circle at 2, and since it's an and, I'm going to graph in between the two of them.